Today, we are diving into something that sounds like it's straight out of science fiction, but it's actually set to become our reality: quantum computing. We're going to break down what it is, how it works, and maybe most importantly, why it has the potential to completely change our world.
So let's kick things off with a question. Have you ever stopped to think that for all their incredible power, the computers we use every day, and even those giant supercomputers that fill entire buildings, might be hitting a wall? Well, it turns out some of the world's biggest, most important challenges are they're too complex for them to handle. And I'm talking about the really, really huge problems. Like simulating the incredibly complex dance of molecules to discover a new medicine, or trying to design a game-changing new battery, literally atom by atom. These are problems that require us to understand nature at its most fundamental, quantum level. And that's something our current computers are, well, surprisingly bad at. See, classical computers, even the most powerful ones we have, they have to grind through these problems step by step, which could take, well, forever. To solve these quantum level problems, we need a totally new kind of computer, one that basically speaks the same language as nature. Just look at this comparison. While classical computers go step by step, quantum computers get to explore every single possibility at the exact same time. Okay, so let's get into it. To really understand how this is even possible, we have to start with the absolute basics. The real difference between a regular computer and a quantum computer. It all comes down to its most fundamental building block of information. Everything, your phone, your laptop, the whole internet, it's all built on this one simple idea: the bit. The easiest way to think about it is like a light switch. It can either be on, which we call a 1, or it can be off, which we call a 0. That's it. It's simple, it's powerful, but it's always one or the other. But what if you could have a switch that was on, off, and kind of floating somewhere in between, all at the same time? Well, get ready to meet the hero of our story, the qubit. A qubit, or a quantum bit, just completely throws the old rulebook out the window. It can be a 1, it can be a 0, or, and this is the part that might bend your brain a little, it can be a combination of both of them at the same time. The best analogy is a spinning coin. While it's spinning in the air, is it heads or is it tails? In a way, it's both. It's only when it lands, only when we measure it, that it picks a side. This incredible both-at-once ability actually has a name: superposition. It's the first quantum superpower we need to wrap our heads around, and honestly, it's where all the magic really begins. This is what lets a quantum computer see the world in shades of gray, not just in black and white. And this slide really nails the difference. The classical bit, that's our light switch. It calculates one thing after another in a sequence. But the quantum qubit, that's the spinning coin. It exists in many states at once, which lets it explore a massive number of possibilities in parallel. This isn't just a little bit faster, it's a completely different way of thinking about information. So a qubit can be multiple things at once. Cool. But what does that actually mean for solving problems? Well, this is where we get to the true quantum advantage. We're basically going from a single-lane country road to a million-lane superhighway for computation. Here's a really simplified look at how it works. First, using superposition, the computer holds all the potential answers at the same time. Then, it uses another wild quantum trick called entanglement. This links qubits together, no matter how far apart they are, so they act like one big connected system. This helps it quickly narrow down the search, kind of like amplifying the right answers and canceling out the wrong ones. And then finally, when we measure the system, it collapses out of all those possibilities and into the single best solution. This quote just sums it up perfectly. A regular computer is like trying to solve a maze by walking down one path, hitting a dead end, turning around, and trying another path. But a quantum computer, it's like it gets to float above the maze and see the whole thing at once, instantly spotting the direct path to the exit. Now, this incredible new ability isn't just for solving mazes faster. It means we can go back to those huge, world-changing challenges we talked about at the beginning, but this time, we have a tool that's actually powerful enough to solve them. And the potential here is just staggering. Think about it. In medicine, designing drugs that are perfectly tailored to your personal DNA. In finance, creating encryption that is physically impossible to break. In AI, supercharging machine learning to learn at speeds we can't even imagine. Or inventing brand new materials for super efficient batteries and solar panels. To really, truly get a sense of the scale of this leap, I want you to just look at this number. Just let it sink in for a second.
200 million. What on earth could that represent? Well, that is the number of years. Let me say that again. Years. The world's most powerful supercomputer would need to solve a problem that an early quantum computer did in just 200 seconds. This just brilliantly shows the difference. It's not about being a little bit faster, it's about making the impossible possible. Now, with all this incredible potential, it's really important to remember that this technology is still in its early days. I mean, we're not going to have quantum laptops tomorrow. The journey is really just getting started. But look how far we've come, from those first simple processors back in the 2000s to a huge moment in 2019 when quantum supremacy was first claimed. That's basically the point where a quantum computer does something a classical computer practically can't. Right now, scientists are working on building bigger and more stable machines. The future is all about scaling this power up to solve those grand challenges. So, the crucial point is this. We are witnessing a fundamental shift in what it means to compute. Let's just boil this all down to the key things you should walk away with. So here's your quantum takeaway. First, computing is moving from the simple on-off world of bits to the on, off, and both world of qubits. Second, that change lets them explore a huge number of possibilities all at once. And the result? It's the power to solve problems we used to think were absolutely impossible. And all of this leaves us with one final and pretty profound question. As this technology grows, the challenge is going to change. It won't be about if we can solve a problem anymore, but which problems we should choose to solve. When every problem becomes solvable, which ones do we tackle first?